Thank you, JJ. Well, hopefully it'll all make sense. If it doesn't, throw your hands up. I'm going to get you guys to put your geotechnics hats on. How often do you do that? Right, because we are going into the ground. It's the dark art of geotechnics. I'm going to try and demystify what this is all about. I've already just had a chat with Paul there. How many of you guys have been involved at any point in time with grout injection in the ground? Oh, good. I'm going to dispel some myths hopefully this morning, because there's some funny hocus pocus out there about grout injection. So that's me. We've got actually Mike and Alex at the back, who will be bored to tears with this because they heard this at a party wall surveyors meeting, which is their fault I'm here. That's myself. I only put that up because that's my colleague Simon, and he and I invented this system. So we are co-inventors and cohorts. A little bit about the stress group. You've got it in your book, so I don't really need to tell anything about that. But basically, we repair and strengthen anything from the foundations for structures right the way through to listed buildings and monuments, bridges. Anything interesting, we absolutely love it. And so I am actually a geotechnical engineer. So I used to be a consultant. I worked for Arabs, and I got drawn to the dark side of contracting about 36 years ago, and then set my own company up 30 years ago. So that's the history of it. So lots of experience and painful experiences. So that's what we're going to try and do today. What are we actually trying to achieve? That's the point. There's absolutely no point in pointing and squirting things if it's not going to achieve anything. So, and if it does, then what's the science behind it? How are we going to make sure it works? We're engineers. We actually need to know, if we're going to recommend something to somebody and design it, it works. There's no point just going, well, it seems to. And that one, what types of soils does it not work in? That's the really important thing, Paul. That's what we were talking about a little earlier on. So, what I'm going to do today is hopefully show you how we change that into that. Without digging a hole. Okay, so that's the important thing. We're not going to dig a hole. So, where's me doodah? We've given it the name permeation ground engineering, and you'll see why in a minute. Nobody else does, but we have. And it's the science of forming a solid using two things. One, the soil, which I was rattling around in that tin there, and a fluid which will bind it together and turn it into something solid like that. And obviously the purpose is to increase the foundation strength. So we talked to Alex, was talking about underpinning and party walls, and you'll see bits and pieces around that. So, what is the task? Well, it's to deliver that fluid where you want it. Not kind of over there or a bit down there. It's got to be where you want it, in the quantities you require. You guys get involved in, well, you don't do QS work. You seem to laugh about QS, but they have a purpose. And so they will want to know, as your client will, how much is this going to cost me? So it's not a bit like, well, it's about this, it's about that, and here's an extra bill because we used a bit more resin, and there are people who do that. So we want to know how much you need. That's the important thing. So, do all fluids behave as you would expect? That's the other thing. You kind of think, I don't know, cement grout, does that ring a bell with you guys? Have you seen it mixed in a bucket or ever used or pumped or any of that sort of thing? It's the most common grout that you can use in the construction industry. Reason being, it's cheap. Cement, water, that's it. You might put a polymer of some sort in it, just an SBR or something like that, just to make it flow better. But generally, that's the cheapest thing you can do. But cement grout works completely differently to a Newtonian fluid. Now, example of Newtonian fluid: gin, whiskey, water, oil, petrol. Anything without particulates in it. Particulate fluid, we've just talked about, cement grout. So, I'm going to show you a little demonstration here. Two types of soil. One, a very fine sand, sort of thing you get on a beach, and probably the most permeable soil on the planet, sand and gravel. Very similar to the stuff we've got in there. Watch what happens when we introduce a Newtonian fluid. Now, I do this demonstration because I think this is what you all will understand naturally as permeation. We just watch the fluid soaking into the soil. And I want you to keep that image in your mind, because that is what we're going to try and achieve in the ground. Okay, so it's just creeping through, no pressure, nothing's pushing it there. That's saturation. So the fluid is literally working between all the particles and saturating it. Right. We're going to do exactly the same thing, exactly the same sand with a particulate fluid. Similar sort of viscosity. Doesn't even go a millimetre into the sand. Okay? So what does that tell you? Well, it basically tells you that a particulate fluid cannot be forced into a soil. Well, that's incorrect for a start, because you can force it into the soil. But what happens is that the filter that's built up along there of all the little particles that jam up between the soil particles, and then more cement particles come up behind that and they jam it up, you end up with a filter. And the only way you're ever going to force more of that grout into the ground is by increasing the pressure. And you keep increasing it, and you keep increasing it, and the filter grows, and the filter gets bigger. And then finally, you will actually get hydraulic fracture. And what happens is that the grout will then cut its way through the ground, between the soil, push particles aside, and you will get little veins going out all over the place. That's fine. You've put grout into the ground. Have you put it where you want it, though? You have absolutely no idea where it's gone. That's not the point, is it? It's a bit like a foundation, isn't it? I mean, dig a hole in the garden, stick a load of concrete over there. Well, stick some concrete in the ground. Do. Yeah, but the house is over there. So it's really important that we need to guide this material where we want it. You cannot do that with cementitious grout for that reason. And the science behind it: the particles jam up between the cement particles. That's ordinary Portland cement. That's microfine cement. So microfine cement will go a little bit further into the soil. And by the way, that white fluid you saw there was microfine cement. So that's how little it will actually go naturally into the ground. If you use a Newtonian fluid, it will nicely soak through, as you saw that red fluid go into the sand before, and then tail off. You're only giving it a certain amount of pressure, and that's how far it'll go. We use something a little different. We developed it with a company called TAM, actually. It wasn't Normet. Normet bought TAM out. And it was a hydroreactive polymer, which means it reacts with water. So that is the catalyst that sets it off. So the natural moisture in the ground will set this polymer off. But the material that we experimented with was too expensive, wasn't low enough viscosity, and did I say too expensive? Too expensive. No, it's going to be. Oh yeah, the reaction time was just not quite what we needed. So we got them to work on it. They reduced the price, reduced the viscosity, and we got the sort of control that we need. It's now called Geotech LV. Anybody can buy it on the market. We use it exclusively for this process. And when you introduce it into the ground, it nicely comes along, tails off a little bit because it's more viscous than sodium silicate, something like that. But then this is where the reaction starts. And the reaction is the generation of microfine bubbles of CO2. And what that does is lubricates that material. It makes it of lower viscosity, and of course it's expanding. So it gently pushes itself out through the soil to the distance you want it to, and then it stops reacting and sets, and then you get that. So that's really the process. So, doesn't sound too hard, does it? Pipe in the ground, squirt some resin in it, job done. So why do we need to invent a new piling system? Right, I'm going to tell you a little story now that involves that company you were talking about. We've done insurance works for years, forever, and this was going back nearly 20 years now. And we'd got a job. I'm a geotechnical engineer. I'd actually seen this process and thought, oh, that's interesting. This could be ideal for one of the little jobs that we've got, which was stabilising a slab that had settled under a conservatory up in High Wycombe. And so I got agreement from the insurers to try it. I went along to meet the technician. Nobody else came along. He didn't know how I was, and I didn't tell him. I just asked him what he was doing. So he said, right, well, what I've been told to do in this conservatory is I'm going to drill 25mm holes in the slab at 1 metre centres, and then I'm going to get this great big long drill bit, 1.5 metres. He was injecting to 2 metres, that was the design. 1.5 metre drill bit, and I'm going to drill down. I want you to think about every stage he's doing, see if you can see whether he's done it right or not. You drill down and you go all the way to the bottom, pull it out, go into the next one, and the next one, and the next one. So I said, what happens now? He said, well, I'm going to go and get some copper pipe, 15mm central heating pipe, and I'm going to drop it into the hole, and I'm going to grout up that with some epoxy, and then I'll go and have a cup of tea. And when I've had a cup of tea, I'll come back, it'll all be ready to inject. So I said, great, off you go. So he came back after his tea, and I said, so what happens now? And he said, well, I've got these 3 heated lines. They bring all the polymer in. It's 3-part, and it's all mixed at the head. And I put it in through the nozzle. So how much do you put in each one? He said, loads. So I said, loads? I mean, aren't you given a specific quantity? No, he said, we're told to put as much in the ground as we can. All right. He, again, didn't know I was the client. So when that bill comes at the end of the day and there's extra resin in it, he ain't going to get it. So I wasn't going to tell the technician that. Anyway, off he went. He'd done about 3 in a row, and there was a knock at the door. Now the client of the house was out. I was the only one in, apart from the technician. So I went to the door, and there was a very, very irate lady at the door. So I said, can I help? She said, are you working here? I said, yes, we are doing a job. She said, well, I don't know what's going on, but would you stop in case it's anything to do with what you're doing? So I said, yeah, absolutely, certainly. So I told the technician to stop, hurried next door with her, and I said, what's happening? She said, well, I was in the kitchen, and I noticed that my washing machine was starting to move across the kitchen floor. So I said, you're joking. So I'm already thinking, right. So into the kitchen we went. Not only was the washing machine moving, but all the wall units were moving, all the tiling was cracking, and they were going to fall off the wall. So I said, look, let's just get out. Here's my card. Get hold of your insurance company. I'll get a hold of my subcontractor's insurance company and just tell them they've got to sort this out. This is a nightmare. So I'm going back thinking, oh God. So I went back, told the technician to pack up, go. I knew we'd blocked the drains up properly because I'd follow all the protocol, making sure everything was all right. And I'm thinking, what the hell happened there? So I sat in the car for a while, and I just thought, I can see what the guy's done wrong. Think about it. He's drilled a 25mm diameter hole in the slab. He's drilled a 25mm diameter hole in the ground to 1.5 metre depth, and he's put a 15mm diameter copper pipe in the middle of it. So all the way around the outside of that is a gap. So when he sticks his high pressure resin out the end of the pipe, where's it going to go? Straight up the side of the pipe. Out under the slab, right? What none of us knew, and this was, well, I think it was fortunate. Shame for the lady next door, but fortunate for us. It went into a duct that nobody knew about, that the developer had put across 4 houses at the back, presumably for running a cable or cables or whatever. And it had gone under next door. There'd been a gap in the pipe or a break or something like that, and gone straight up the cavity wall, and then started to expand. So it pushed all the block work off on the inside of it. So in other words, see what I mean about fluids not behaving as you want them to? They will behave as they want to. Okay, so your garden hose, there's a hole in it. It will all that water, 2-3 bar, will always find its way to lowest pressure. That's what grout always wants to do. So you try and force it into the ground, it'll just go, where's easiest? I'm out, and that's what it'll try and do. So it came to the top, into this pipe, along, up, now. So that technique that they came along with doesn't work. And by the way, they still do it. Okay, we'll come to that in a minute. So we had to invent, so I'm a geotechnical engineer, so back to basics. If I was going to do that job, how was I going to do it? We need something much more sophisticated to make sure we get the resin where we want it. Aha! A pipe with loads of holes in it. Genius. There it is. Nice and heavy, you can pass that round. Nice steel. So we can get over that gap round the annulus, because you should never drill. If you drill into something, it's got clay in it. Otherwise it won't stay open, so you'll never get your pipe in it. That's one thing. And two is, if you drive that into the ground, it will, the ground will be tight around it, so therefore the resin won't want to find its way up. It'll just dribble out sideways, because that's the easiest thing for it to do. Well, that was the theory. So there we were. We started experimenting. We got about 2 meters of these, and we drove them into the ground, and we stuck our packer in the top with the injection hose in it, and we started to inject. Low pressure, 1 or 2 bar. Where did the resin come out? Top. Yeah, just came out the top. Easiest place for it to come out. So we ended up with something that was a bit like that, carrot shaped. So all the resin flowed out this way, but not down that way. That's not the answer. We're going to have to put a valve in it. So so you can imagine my thoughts there. Oh God, this is going expensive. So here's a blue piece of one. You can see now that we deliver the resin into various chambers. So you divide that lance up into chambers with a valve, non-return valve, and that little tube, the delivery tube, actually goes all the way down to the bottom, and we start at the bottom. Now, when you inject just that one, then the resin could go all the way up that way, but actually the easiest thing for it to do is just go sideways. And we only want it to go about 125 millimeters under fairly low pressure. So actually it just goes, oh, go on then. And it just sort of sidles sideways. Which is great, because you've delivered it where you want it. Then you pull, when you've delivered the amount of resin you want, remember, not loads, but the right amount, and I'll tell you how much in a minute, you pull it up into the next chamber, the valve shuts, and then you're only pressurizing another 1 chamber. So again, the resin then just comes out. Does that make sense? Mm-hmm. Right. Did it work? That was the other thing. So that was the theory behind it, and we did lots of experiments. So here we go. So again, we'll flick through these, but that's basically what we're doing. Continue pumping to the required quantity. So we had to do experiments to find out what the required quantity was. I mean, how big do you need these things? What sort of capacity do you need in them? What's economic? All those sorts of things we had to think about. And actually, what it works out at is about 15 litres per metre of lance. Quite simple. We maybe go up to 20, depends what sort of loads we're trying to take, but somewhere between 15. And 20 litres per metre. So that's easy to gauge. So our guys on site will put 15, if we say 15 litres, they will put 15 litres for every metre, or 7.5 for every half metre chamber, all the way up to the top. So they never walk away from site with any resin. We've given them the amount, the design amount, and that's what they use. And we make sure their vans aren't big enough that they actually can carry it back. So that's basically what we do. And you pull it up into the next chamber and you start pumping again, and so on. Okay, so let's quickly flip. You've got all these pages in your book which you can, I don't know what you can do with it. But basically this is it. We'll quickly go through it. So if we were doing a domestic underpinning, which we do thousands of, you don't need to dig in the ground. You just need to expose the top of the footing, be it concrete, be it a Victorian brick corbel, doesn't really matter. And we'll drill a 40mm hole through it. Now, what was these? I didn't tell you the diameter of these. These are 33mm diameter steel tubes. And so there is an annulus around that, but we fit a gasket on the top, which is when you drive it into the footing at the end, it will actually, it will seal to the top. So there we go. So we drive these things in to the depth we want, and we design the depth. We've looked at the site investigation. We know what the material is down there, and we know where it's firm to found this house, this foundation, this base, whatever. So we keep driving.
What are you driving with?
Aha, come to that in a second. There we go. Actually, the pipe is already in because you can't feed it back over the valve. The valves are one-way valves. So in fact, the pipe's already in, but that's just a graphic that we don't like. Then you start pumping, right? So this in your mind, you're thinking, this is what's happening in the ground, okay? We think. We're pretty sure, but we'll show you how sure later on. And you just keep on going. All the way to the top, you deliver the right amount of resin. It reacts, and you formed your pile. Now they're quite significant things, these. Now that house is already sitting on the ground. So it's not as if it's sitting in midair. It's actually, we're giving it additional support. The support you would get from underpinning. If we did need to support that house on those piles, it would be perfectly adequate to do that. I ask engineers this, and they don't know the answer, so I'd be very pleasantly surprised if you did know it. Does anybody know what stress the ground needs to take to support a two-storey house? Great question, isn't it? 0.25 newtons per millimetre squared. Okay, so that's not a lot. If you think that 20 newton concrete is 20 newtons per millimetre squared, this is 0.25. So when we see underpinning concrete being specified at 35 newtons, we don't really know why, but that's an engineer will decide on that. So actually,
how are you going to do it further along then when the wall's there?
Because down the side of a wall you've always got the footing coming out. So you go in at the side of the wall. You'll see that in a minute. But good question. So there we are. This is actually up in Stoke Poges. It's a little house in Stoke Poges, and we were going down to 2.5 metres. And so you can see we just exposed the top of the footing. This is 1938 structure, and that's how we drive them. So in fact, it's so easy. We don't need an excavator. We just have a road breaker.
And would you have not gone into the duct doing that?
Well, because the resin doesn't leak, we know where it's going. Then it shouldn't do. But you're right. If we'd exposed, if there'd been a duct just under that, we could, in theory, have gone straight through the duct.
Hopefully you'd have seen it when you.
But we'd have seen it, hopefully, and you're only going to influence that top little bit in the last bit of the lands where you're going through, not all
So you can drive the full depth with a road breaker, pretty much.
27 metres we've been to with that.
Can you?
Driving those.
And if you hit an obstruction, it's a sacrificial, and then you do another one next to it or something?
Correct. Exactly that. We'd really want to know what that obstruction is, but
Yeah.
yeah, so you do the full services surveys, you check everything out obviously before you break ground. Sometimes I say break wind when I do that, but break ground. And yes, you need to know your geology fairly well. You know, you want to know what it is that you're going to go to. But sometimes, yes, you can hit a cobble, something like that. And the guys know, because they know how quickly this thing should go in the ground generally. Now we're doing a job at the moment in central London. It's like you'll see an example of it later on. It's a pre-consolidation of some material to assist the construction. And so we are driving through terraced river gravels. Most of these for domestic jobs are because there's been washout somewhere from a broken drain, broken water pipe, and it's washed out the soil. And so we are then consolidating that soil and making it good. So we are driving through full terrace river gravels to 7 meters, just using those. And we've done phase 1 already, so we know it works.
And you said that you know the quantity of litres, but what if you get rivers of bad pockets?
Potentially, there could be. You're right. There could be a void. What the guys they do always have a little bit in reserve,
Okay.
but they listen to the pumps, and the pumps are tiny. You probably see one in a minute. They're only about that big because they're low pressure, and they just go tick 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 tick. So suddenly, if there's a void comes up, they'll suddenly go tick 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 tick. The kind of guys go, that's interesting. So we will monitor that and record it and just make sure. Sometimes happens, sometimes we're asked to do voids under slabs. Slightly different in the way we do, but another good question. So there we go. An exposed footing, nice and neat. That's inside a house. So you can do exactly the same inside the house without actually decanting them. This is why insurers love it, because quite often you underpin a house and you don't actually, those people don't even need to move out. What does it look like? Well, it's something about that big. So that's what I mean. I mean, that stuff, you can all come and have a play with that any time. That's exactly what it's like. If you took a spade to that, it would ring. It's hard. How hard? We were saying 2.25 Newton per millimetre squared to support a 2-storey house. We've done testing on it, this material, lots and lots of testing, and all different types of material and different types of soil, to get a gauge as to what the reliable strength of this material is. And we bring it right down to 3.5 to 5 newtons per millimetre squared. So for you guys, you would think about a medium dense concrete block. That's the sort of strength. So you could take a hammer to it and break it up, or you could chisel into it if it was a thermalite block. Same thing with this. You can actually trim it with a Kango. But that's what you get. So it's this thing, sort of ugly shape. There's one look we dragged out. Now what you probably notice is that the lance is still in there. We can't get that out for love nor money. That's in there that's it. It's only a delivery tube, but we can't get it out. Why it's an advantage is that, what if we had a little layer of clay, compressible clay? So this part, which is right under the footing, consolidates that bit, and then the rest of it wouldn't know, and your house would still have 10 millimetres of settlement. But what happens is that this material sticks so hard to this, I mean like ridiculously hard, that in fact it will use that steel shaft to actually bypass that clay and distribute the load below that.
What that doesn't permit you to do though is to add an anti-heave material.
Correct. But that's what we were talking about earlier on, the right type of soils. So how many of you have come across schemes where polymer has been injected into clay?
I've resisted it.
Well done. Right, I'll give you a fact. We do a lot of work for insurers. We've worked for them for years. I get on panels. And I've been banging on about this for that full 20 years. And I'm going to say it. There's a company called GeoBear, and they are advertising at the moment that they can sort all problems out. Clays, they can stop houses heaving, protect trees, all the bits and pieces. No, they can't. It's absolutely impossible. Doesn't matter what resin they use. Tell you why. When I did my MSc in soil mechanics, one of the things I had to do was to take some clay samples, little ones, little 50 mil diameter, about 85 mil long, and impregnate those with a wax. Now when I say a wax, I'm talking about something of lower viscosity than turpentine. Okay, so lower viscosity in water. 2 months under pressure it took me to get that material into those little samples. So what are the chances of anybody squirting a foam into clay and saying that they've impregnated it? No, they haven't. Oh
Well,
yeah.
they come from Scandinavia, where the buildings are slowly going into the permafrost anyway. And then, come
Yeah.
on, I mean, GeoBear's been going for years.
Yeah, but what they're doing now is they're telling people that they can inject clay, and they can't. It's absolutely... well, I tell the feedback of that, I mean, obviously I'm always happy to be corrected, but I was at a meeting with Aviva about 6 weeks ago, and they sat down, and the first thing that this outfit said to me, because it was all about subsidence, was, "You were right, Dave." So what do you mean I was right? We are now getting up to 50% failure rates in these polymer injected jobs that have been done by this one company.
So across the board, not just
Yeah.
clay.
Oh, I don't know, but I imagine it's mostly clay. But we reject about 70% of the jobs that we're brought because the soil is not suitable.
What job were you doing in London? And what soil was it on?
Oh God, I've done so many in London. It's Ennismore Gardens, actually. It's up near Imperial College. Yeah, I'll show you it in a minute.
On clay.
Yeah, I thought so.
Terrace River Gravels over clay. That's the thing. So as long as you...
So technically this is very limited in the London basin, that's what you're telling us.
Almost anything south of the Thames, it won't work. But north of the Thames, there's lots of alluvium, there's lots of terrace river gravels. It's fantastic for it. And a little bit further west you go, the better.
Sure.
Chalk, again, is a bit like a clay. No, you can't impregnate it. Because the first bit of weathered chalk generally is like what they call a putty chalk. So it's been mashed around by, you know, tides, well, the alluvium coming down, that sort of thing. So you end up with a kind of soft band of chalk. If there were voids in it, then potentially if you can find those fissures, those voids, you could grout them up. But you wouldn't necessarily use a polymer if you were going to do that.
So
So
your site testing, you must drill boreholes and you need to establish...
we need to establish exactly what's what. So firing a high expansive foam into soil, from what I've told you and you've seen today, with permeation, the way it actually moves through the soil doesn't work. It doesn't work on any level unless you can permeate it. It's as simple as that.
Why, can I just ask why you would take it out?
Oh, that was an experimental one.
Oh, okay.
So in other words, we did loads of these where we needed to be sure before we went on the market just what we were getting, you know, how strong they were, what distribution we got, and until we were happy, we didn't go on the market with these things.
Can I just say what GeoBear told me was if you get it with a subsidence, it's not that you're permeating the soil, it's that you're actually using their product to pump.
To re-level.
Yeah, so for instance, your conservatory slab, it would just be, they say, pushing the slab back up into place.
Yes, and actually, I've got to say they are very good at levelling slabs and roads and things like
And
that,
that-
because that's what they're doing. They're filling a void with an expansive foam, Yeah, they do that.
So then, I mean, in my mind, when they described it, it's not even a void at that place because it's all slumps, but they're forcing it out
Yes.
and creating another firmer.
Yes, and in that respect, they're perfectly good at. They are good at that. But if they're telling people that they are changing the quality and the strength of the ground, that's a different thing altogether.
Yeah.
And so, I mean, you saw how difficult it was to actually get anything into the ground. So if you're going to put a highly expensive resin in, what some people say is, yeah, but it expands and it forces the ground apart, and therefore you're consolidating it. Well, I've never seen any evidence for that yet, and we've dug up some previously treated ground, and we can't even find any resin, which again backs up my fear that in real terms, a little bit of expansive foam is not going to do anything at all. So that's how certain we need to be before we ever launch this on the market. And so if we're doing, when I go on, some of the things I'll show you will hopefully also back up what I've been saying. So, a typical terrace house like that's, you're going to 2.5, 3 meters, that's what you would see in cross section. Diagrammatic, but that's kind of it. So let's recap. We've got these reinforced piles, 1/2 metre diameter, up to 14 meters or more. That's not economically viable, unless it's a very rare circumstance that you're going to be able to afford to put something in 14 meters in depth. But we have, and we've tested them. We've tested them up to just under 21 tons on a job that I'll show you in a minute. And that's extrapolated with a factor of safety of 3 of what we would get on a capacity of a pretty deep pile. And remember, this is all installed through a 40mm hole. So that's the beauty of it. So what are the advantages to the industry? Well, safety. You're not going to have any holes in the ground with underpinners in them. I mean, I've got 3 underpinning crews, and I worry about them all the time when they're down there. But they're well trained. They know how to brace the excavations and operate properly, and we have forced air and all that sort of thing. But if you don't have to put them down there, it's a really good thing. And of course, you don't have to take all the muck away from site. And again, everything is a carbon footprint nowadays, as you know. And if you don't have a hole in the ground, you don't have to bring concrete back in. And that obviously has a huge carbon footprint. So those are 3 quite neat benefits for this system. We engineer it, so we design these things so we can actually get a latent defects warranty on it. So that's something as surveyors quite often, or certainly that you guys ask us on a specification, give us a price for that underpinning, but we want a guarantee. So we can guarantee this, insurance backed. Economical, well, this is reassuring the expensive stuff. So we're talking about cement grout, 70p a litre mixed. Our stuff, £7 a litre. So you want to use it sparingly, which again is coming down to real costs for the client. Use as little as you need to. But we need to be, have an engineering certainty that what we've used enough, and so you balance it out. So economic in the right circumstances. So we know that instead of chucking somebody out their house, tearing up all the floors, or all around the house, all the bits and pieces, the economics of us nipping in for a week and underpinning a whole house start to make sense. If the access is difficult, suddenly it makes more economic sense. So there's a safety, that's kind of how it works. So it's a tool, it's not for every job, and it doesn't work for every job.
Can you use that then semi-horizontally as a ground anchor?
Yes.
And how would that then compare with something like platypus, cost-wise?
Hugely more expensive, but much bigger capacity. So again, in the right circumstances. But again, you've got to get your soil right. But yes, yeah, and we fit platypus anchors as well. So this is a bit of a joke, but we have actually installed these things from understair cupboards because you only need that breaker, and we can break these things down into 1/2 metre lengths if we want, and knock them down and keep knocking them down. As far as we know, it's the only fully patented, designed and guaranteed permeation ground system in the world, and it is world patented. We talked about underpinning, you've seen that, and the piling. Anchoring, thank you, you nicely mentioned that. Do you remember we were talking about how well this material binds to this steel? Well, this was a complete offshoot of, we weren't expecting it to do this. And I asked Simon, who's a materials engineer, to test a bucket full of this material. So put this in a Travis Perkins bucket, about 300 ml long, consolidate the material around it, don't do anything to it, just leave it as this bare steel, and then we'll take it next door to where the guys have got a press, and we'll push that steel. We'll just find out how much force it takes to push that out of that lump of consolidated ground. And he came back and he went, 2.75 tons. I said, no, that's rubbish. That's an absolutely ridiculous number. It's way too high. So tried it again and again and again. We kept getting the same results. So we did some other tests and we realised actually that the bond strength to this is phenomenal. So we use it as ground anchors. But generally, if it's for permanent works, you'll need to have it in stainless steel, because obviously that strand is then going to be there for 60, 70 years or whatever. We need to make sure it doesn't corrode. But in essence, yeah, you knock those things in to the depth you want, expand, sorry, not expand, but you permeate the ground over that maybe 2.5 meters, allow that to cure, and then you've got phenomenal capacity.
So actually it's an even better system than a basic platypus.
Well, it means you only need to put a 40 mil hole in the wall and put it through, but the soil's got to be right, so you need to get over the back and obviously check
But
it's okay.
you're relying on a much wider then area of resistance to putting out. So.
Exactly that.
Yeah.
And so we haven't done many, but we have done a few. We can jack off the top of these things. So we were talking about there earlier on about GeoBear lifting slabs. Yeah, again, they're great at that. We can actually jack these slabs off the top of these things because there's so much capacity there. We put these little jacking heads in, and we can mechanically lift slabs and then just put cement grout under the slab. So again, it's got to be the right. This is a tool. It's not the be all and end all. And so we pulled, small buildings, garages, extensions, things like that. We've pulled them back up to level because it's an economic way of doing it.
So what soil are you talking about when you're doing the jacking?
Well, generally it will be non-cohesive soils and fills. So your terrace river gravels, a lot of the alluvium that we find around the place, quite a lot of fills actually. They just put rubble back, that sort of thing. You can consolidate that perfectly.
Can it be used as a construction material as opposed to a repairing material? And is there any chance of getting the production costs down? Because it sounds like you could build a slab with this.
Yes, you could.
And not worry about it needing repair later.
It wouldn't be stronger than concrete, and therefore, and obviously a lot more expensive than concrete. So chances are, unless there was somewhere you just literally couldn't get to with anything else other than a 20-litre drum of this stuff.
Tensile strength is no different. This is about accessing.
This is about access. And of course we're looking at something that generally is a lot weaker than you would find concrete. So it's in the right circumstances. And ground consolidation, and I'll come into that in a minute because this is where temporary works come in and where some of your questions will come from party wall issues. Design, you're not really interested in that, but we use a pretty well-known expression for bearing capacity. And all we need to know from a site investigation, if you were doing one for us, would be the soil down to a decent depth. No point going down to 1.5 meters, that's no good. We need it to 5, 6, 7 meters. Because we want to know what's under it. We need to know the type of soil we've got, so get bags of material up and get that sieve analysis done, and SPTN value, so that we know the density. Because we want to know where to found these piles, these new piles. but simple as that. And we use a factor of safety of 3, so we make these pretty damn robust. Solvay House, we're working on this at the moment. This is up in Southwold. You may know it from holidays. A lot of sand up there, so this is ideal. A lot of Ipswich and Norwich is on sand. We do a lot of work for Norwich City Council with washouts, burst pipes, that sort of thing, creating settlement. Solvay House had all sorts of issues over its time. Then it was going to be reused, so they were knocking out walls, putting new walls in. They needed new foundations without having to go inside and other bits and pieces. So we do a plan and we work out where they need it. And this is just to literally illustrate what we do. We mark on the drawing so that everybody can see what part of the geology we're actually going to consolidate. The guys can see it, they know what sort of depth, they know what they're going to expect, so that if there are any of those, you know, you were saying about what if a void came. If they're driving these things and suddenly it goes, they record it, and we know we've got a void there. So they do that. We do drawings for each level so that we know what it is that they're trying to do. They're putting a new basement in there, so they're doing the excavation to support the walls. Very straightforward, nothing very elaborate on there. So here's an example. Now this is a solution feature. How many of you guys have been involved in solution features? I was surprised. It's about the first time. Solution feature. Swallow hole. Swallow hole? Swallow hole appearing under a person's property or garden. Yeah, sinkhole. Yeah, sinkhole. Solution features in geology, in geological terms. And so this was Maidenhead, this was Boyne Hill House, which used to be a priory, and within the grounds...
There's something wrong with this space here.
Oh, is that? Technician?
Phone.
Wait.
Someone's phone's just going off.
Is it? Is that one? Is that one buzzing away? Is it flick your off button? Flick the off button.
No, no.
Oh, I see.
Can you give me this? I think it might be the petrol. Carry on.
Can you hear me all right?
We can.
Yeah.
So, no, a good point. I heard it actually making a bit of noise earlier. So what they needed to do, they needed to create stone columns for their new housing. And so they used something called vibro replacement, which basically is a big rig, like a piling rig, but it has a poker on it. And that poker vibrates its way into the ground, therefore pushes the ground aside, so you're densifying it. But as you pull it out, you replace that material, that void, with stone columns. So you end up with these stone columns in the ground with pretty high capacity, onto which you can then put foundations of four-bedroom houses and such like. So that's what they were doing. This is alluvium over chalk. And it was very wet November. They were banging away at this thing, and the vibration suddenly knocked the plug. The solution features is generally this sort of shape, and it has a soil plug in it, and that gets either washed out or vibrated out in this particular instance, and down it went and took part of this building with it. Because nobody knows, we all build our buildings straight over there, did in those days anyway, straight on the land. You don't know whether there's a solution feature there or not until the solution feature opens up, which is why you see buses disappear into roads, gardens, and holes appear in gardens, that sort of thing. This happened here. Is that better? Yeah, that's what I was. Is that better?
Yeah.
Can you hear all right? So you can see what happened to this old building. It really started to go. If you went down to the basement, these are the sort of cracks that are appearing. So it had gone down, it had damaged a whole series of walls. NHBC came to us because obviously they were supporting the developer, and we got on board with them to try and work out what to do. So we did probes all over the place. You'll have seen various site investigations with probes on them. And it looks like a molar. But that was roughly the shape of that solution feature. that we could detect by taking the plots and plotting them on the ground. And then we designed the system. So we needed to support individual walls, different loads to different depths, and that's what we did. What we did actually try and do, because the client requested it, to see whether we could fill this void up. So we put a tube down, just an ordinary tube, not one of our special tubes, and we tried to put in, I think we got close to 20 cubic meters of grout, and you got no feedback from the pumps that anything had happened. It hadn't, you weren't getting a build-up of pressure or anything like that. So we stopped, because you don't know whether you're pumping into a stream, a reservoir. You don't know what sort of damage you might be doing. So we stopped and went back to this system of supporting the priory. And that was the piling layout. Different capacities, different spacings, depending on because nice thick walls, nice big foundations, so you can space these things out. Generally, 1.2 meters is the standard spacing that we would use for a house. Very occasionally, high loads, bases and things like that, we might go to 1 meter. So we had a variety of them there. And when it was finished, because we do all the structural repairs as well, we put the whole thing back together. So this is now, guys, probably 12 years ago. We have been back and had a look. We can't find any defects at the moment, so we think it's doing its job. This is slightly different, but it's another solution feature. And believe it or not, I've got to go back and have a look at this. So this property up at Lane End, little cottage, it's actually got another cottage on the side of it here. This is downhill. Hill goes down that way. Lady phoned the insurers and said, she'd gone down to a basement and her boiler had disappeared. So we went to investigate. We got some probing done. Very difficult to do. I had to go inside the house and do probing bits and pieces. And we detected the size of this. It was quite narrow. And we got a site investigation done, so we knew what sort of material this was. And we could just about grout it. We weren't super happy about it, but it wasn't a capacity thing that we were looking at. So what we actually did was we created an umbrella of our lances down over the top of this solution feature, so that we could actually put an RC slab over the top of it and support it, because we could actually hear water down here. So you can't start pouring grout down or even foam concrete or anything like that, because you don't know where it's going to go. That was fine, absolutely no problem at all, until I got a call on, where are we now, Friday I think. Engineer friend of mine said, well, I'm dealing with these pair of cottages up at Lane End. Would you come on board with me and we'll sort this foundations out and other bits and pieces? What's the name? It's an Ivy Cottage. I said, oh, for goodness sake. Now what's happened now is that this has migrated, or what we detected as the sides of the solution feature are now migrated, and it's now starting to take in next door as well. So those two pairs of cottages are going. Somebody's bought it knowing that, but they don't know what to do with it. They don't know what sort of foundation to put over it. So that's where I'm getting involved again. So that's pure coincidence that's come back. How do we know it works? So we're talking about that, we're still injecting into the ground. How do we know that works? Any small gardens? Remember we talked, this is the one. And that piece there has come from any small gardens. Abbey Pinfords, heard of a company called Abbey Pinfords?
Yeah.
Yeah, they went into administration about a year ago. We did a lot of work with them. They're also asset contractors, Association of Underpinning Contractors, the same as ourselves, but we do different things. And therefore, we kind of complement each other on certain jobs. And this one, they said, we've got a problem. We need to construct a two-story basement below the existing single-story basement of this property here. So you go downstairs, and then there's another basement below that, and they wanted two below that, all right? Which took them into the terrace river gravels, absolutely fine. Then they hit the water. And if you know, you've looked in a trial pit or anything that's had terrace river gravels, I mean, you take a spade out, the water comes in, it brings another spadeful back. So it will just flow in. So you can imagine the net worth of these people here. We're talking party wall issues here. Russian client for this one, number 40. Well, it's not number 40.
So
It's
you've
number
got paid
6.
then.
So, well, that was one of the worries. And actually, what happened was I asked to come up with a scheme. I came up with a scheme and a price, and I was called to an interview at the Dorchester Hotel at 4 o'clock on a wet Friday afternoon. I mean, can you imagine how deflating that is? Anyway, we'll walk in there, and it's a bit like going to Mastermind. There's a black chair in front of a fireplace, a spotlight over it, some settees over here in semi-darkness,
An NDA on the table.
and smoke coming up from the corner over there out of the chair. So I was absolutely, I wasn't petrified, I was intrigued, and then I was peppered with the most ridiculous questions. First one, your price is too expensive. So I just got up out of the chair and started walking towards the door. I said, how can you say my price is too expensive? You haven't looked in. Oh, we've got a cheaper one. I said, well, that's fine. Just get them to do it. And they said, and that's when the smokestack moved, and across came this 6'4" Russian, and he came, Mr. Kitching, sit down. I need to talk to you. So he was interested. And I said, right, this is what. Can I don't want to sit there. Just can I walk around? Right. I'm taking you now down to where we're going to excavate for the bottom of your basement. And that's where the water is. And you telling me that I haven't put enough resin in? How do you know? And he said, keep on, go on. So I said, your subcontractors under Abbey Pinfords have got to dig down to here into the London clay, and I've got to keep all that terrace river gravels and the water back so they can do it. And he went, good point, you got the job. So at that point I started getting terrified, because obviously that's where it kicks in to be realistic. But we did a scheme, we got them to do more site investigation. The level of that London clay changed nearly 2 meters in 2 meters. So we needed much more probing to find out where we were going. And what we designed was this. So, and this is where your party wall questions come in. That is the line of the party wall. I shouldn't do it. It's a square. It looks like the party wall. It's not. It's the material behind it. So we've got the basement up here under the existing basement under the lower ground floor of this property, and then I got Abbey Pinfords to dig down to above the water table and put in their RC retaining wall with a toe on it to take the load. So we're now supporting the party wall and blind it out, and then we drill in with holes, little groups of 5 different angles to create that. So each lance has got a different length to it. So we know exactly how much we've gone, and we know how much resin to put in each one. And that's what we did. And so what you do is you create a zone. Yes, it's at the back, it's next door actually. And so the party wall surveyor had to be involved in this, and gave the go-ahead. He said that's absolutely fine, because he'd seen this. I gave this seminar to them. He'd seen the material. He said, yeah, that's absolutely fine. You're not expanding anything, nothing's moving, therefore there's nothing to worry about. I said, correct. We then got Abbey Pinfords to break off the toe. So this toe came off, and they went into standard underpinning mode again. Reason being, not a huge basement. You've got a client prepared to spend a few £1,000,000. He wants a basement as big as he can. So if you did a seek and pile, you get a little seek and pile rig in there, and it would go down the inside of the party wall. You'd then put a structural wall inside that. You'd have no basement left. So he didn't want that. He wanted to pay the extra to get a full-size basement, with the dimensions of upstairs. And that's what he got. So that's where the water table is. So these guys dug down chipping away at this material with little kangos, trimmed it back, and there was enough material back here to hold back the water. Now, temporary works engineer obviously had to be involved, but remember we've got these pretty hefty rods running right the way through there, so you've got reinforcement there. So in fact, it's interesting how well this stuff sticks together and how much lateral restraint it will give. And we're only allowing them to take out 1 metre at a time. So that's what they did, and the client ended up with a project 3 months ahead of schedule, the basement he wanted, and a very happy client. It cost him £250,000.
So I suppose those tubes actually stop that stuff from washing in.
Once they're bound with this material,
Yeah.
then yeah, you know, if you think about it. Here we go. That's the room. The only way, I mean, have a look at it. There's no foam. There's nothing in it. The only way you can actually tell is to smell it, and it will have a slight sweet smell to it. So you can't, you know, those voids between the particles are so small. So that is actually from this job. Now here's another one. Eriths. You've probably heard of them. Large contractor doing groundworks and RC works, that sort of thing. They came to us with a problem just off Park Lane. And this is a 7-storey listed building right next to the site. And you can probably just see the tops of the secant pile wall, onto which they then had to put a capping beam. Now that capping beam, you can see the level of it, is below the level, or the excavation level, for next door's footing. So, as soon as they do that, this will go down, because this is terrace river gravels. This will just, that's that material. It will just flow, it'll just, literally, the pressure of this coming down here, this will crumble, and you will end up with lots of settlement. So, I'm getting wound up, down. So anyway, we did it very quick. Got in on a Saturday morning. We'd done about 3/4, it was about 38 metres, and a very helpful excavator driver had gone in and he'd pulled just over 20 metres of this out in one hit. So there was this building sitting on like that, and so everybody panicked, and we got them to backfill it really quickly. They got the, you know, they were monitoring this, as you can imagine, for deviation of all sorts. Not a millimetre, didn't move one bit, because it was supported by that material. Now that's not what we designed it for. We designed it for temporary works. This was confined space strength, not unconfined space, but it worked. So I think as I wrap up now, it just gives you some idea of the sort of engineering and surety that we go to make sure this stuff works. So questions, I guess?
How wet can a soil be for it to be used?
Well, as you can see on that, it's below the water table.
Okay.
So it's fully
So
saturated.
yeah, wet
Makes no
saturated
difference.
alluvium, no problem.
It's not so much an engineering question, which is probably not the right forum to ask you, but in that instance, the resin and the rods are all underneath next door, and the next door approved that.
Yeah, that's what I was saying. So in other words, yeah, that's where, so in other words, actually the party wall, not very well drawn, but it's actually right down the middle of that.
And when so if they want to dig their basement, presumably they can just shear it off and dig it out.
Correct. So we had to persuade them, show them the material, and just say, look, if you did have to remove this material, it's not, it's inert, so you don't have to. It doesn't have to go off to special what do you call it? Recycling. So there's that. It's easy to dig, and you will have a lot less trouble with your water if you go. And they just went, yeah, great. A good question, though.
Yeah, you would need permission.
But you definitely need
That's
permission.
a trespass other.
It absolutely. Yeah, no
questions lying
Do you
around.
have issues with building control ever querying the system?
Every underpinning job that's done, we get building control along. They pass it off. It's part of it, local building control, because it's classed as an extension to the foundation,
Yeah.
as is underpinning. So We use Ascent quite a lot, or have done in the past.
Yeah, so you use an approved inspector as opposed to a...
And sometimes local authorities, but we tend to find the ones that...
Because with these specialist systems you get a little bit, building controls, we don't know that.
Exactly, they're a bit spooked. Some of them go,
Yeah.
oh yeah, can't wait to see it, come and have a look at it. And by the time they've seen the first one, go,
Yeah. Probably work.
yeah. So, yeah, there are some other examples that we've done there, and we've done some weird and wonderful stuff in the past, but I hope... Was that of any interest?
Typical cost in a domestic situation?
Good one. The current price, and we do this on price almost anywhere in the country, we just changed the mobilisation fee, would be £480 per metre of lance installed.
Right.
So if we need to go to 2.5 metres along a wall that was 10 metres long, well, we did some. It's literally, it's as simple as that. So it's not cheap.
480 a metre.
So 480 a metre
Per lance.
per lance
per lance.
per metre.
Still substantially cheaper.
So
That's all.
not, yeah, a lot less disruption. So you haven't got a lot less digging, a lot less, and probably, hopefully, less settlement. You know, because he was talking about consolidation settlement earlier on. I think Alex wasn't he? He was talking about consolidation settlement causing damage after your development has been completed. Yeah, so you won't get any consolidation settlement. So that's the beauty of it. But the conditions have got to be right.
So if you've got all the non-return valves, how do you fit sections together as you go down?
The hose. So in other words, if that was one at the moment, we assume that was in the bottom. This hose would go for many metres up to the ground, and we would feed new sections over the top, and then we've got a driving head that you can pull that out of, so that it drives down.
How do you connect the section?
Oh, I see. They are literally they're push fit. They're a tight push
Oh, are
fit.
they?
Yeah.
So the pressure is less inside, so they won't actually burst that connection.
No, because obviously they're solid steel, and you've got valves top and bottom, and that hose will go all the way through. Yeah. So in fact, you don't get any leakage at that point. If we're doing, you're talking about ground anchors, they have to be screw connections because you're going to give them a pull. But apart from that, yeah, no different.
Okay, we need to stop there actually, because otherwise we're going to be